Today, we are talking about direct current and alternating current, or we name them with DC and AC. Direct current, which is DC, alternating current is AC. Now, any electric current, it can be DC or AC. The current, it can be direct or alternating. DC, that's mean direct current, which refers to a flow of charge that always flow in one direction. So direct or DC, it's a direct current. That's mean the current flow in one direction. Flow in one direction. Flow in one direction. Sorry, it's not like okay, that's mean it's a flow in one direction. That's meaning direct current. Where's the direct current we have? The direct current is in a battery. So inside a battery, we have a direct current. The current is going or is flowing in a one direction. It comes from the terminals of the battery. So it's moved from the battery from negative to a positive terminal. Look at this picture here to understand what I mean. Here we have a battery. In the battery, the current is direct. Why? Because it's flowing from a negative, it's from a negative to, it's coming from negative, continue in to reach the positive. Now it's a flow in one direction. So in battery, we have direct current. So a battery produce, give me an example. There's an example of the direct current that's happening in battery. The electrons move from negative to positive terminal. So if it is work in a one direction or like this here, we have a direct current. Some of the current, it can move in unsteady pulses like this here. But this is also a this is also a DC current or a direct current. Direct current, I will repeat, it's a current that's moving in one direction. It's moving in one direction. Look at the example here or here. Both of them are direct current. One of the example of a direct current is a battery. That's the current is moving from negative to a positive terminal. This is the first type. So DC is direct current, which is in battery. It is flow from negative to positive. It's only move in one direction. Now let's talk about the AC or the alternating current. The alternating current here, AC, that's mean the electric current that repeatedly reverses direction, like the sinusoidal. The sine. Do you remember the sine in math? It's like this. Here is the AC. Electrons, at first it moves in one direction, like we said before. Then it moves in the opposite direction. Then it's come alternate back. Then it's forth until it's finish its period. Here, let's have this one. This is moving in one direction. As you see, this is an DC. Now, if the current start moving in this direction, like this here, then it reverses it back. At this point, they didn't continue in the same direction, it's reversed back. in here. Let's see at this fixed point. At the first fixed point of the first point, it comes in one direction. If it is DC, it will continue in the same direction. But since it is AC, it's not continue, it will reverse back. Then it's alternate back. It's forth back until it's with finish. This is an AC. It is an alternating current. So the first one, it's for DC, it's for direct current. The second one, it is for an alternating current. It's not for direct, it's an alternating current. The DC happened in battery, but the AC is in generator. So the DC, battery, AC, and generator, or in another source, another voltage source. So inside a battery, we have only DC, but in the generators, in any other voltage source, we have AC. So let's now here revise what is the types of the current electricity. As I told you, we have an alternating and we have a direct current. Alternating or AC, the current moves back and forth. Okay, with move back, so the very things here, that's move back and forth. This is the with changing magnetic field, it's not with you. So it's a current moves back and forth. This is a type of electricity from wall socket in your home. At your home, the type of current that's reached to your home is AC. It's not DC. In your home, it is AC. The DC, as I told you, it's only travel in one direction, and it is a type of batteries, like YC here. It's move from negative to positive, so it's move only in one direction. But here, inside your home, in a socket in a wall socket from your home, on the generators and the motors, the current here is going like sinusoidal. It's going on a changing the direction as we see. So that's why we have an alternating current. Now, by now, is it clear?
Yes, yes. Yes.
Yes, teacher.
Okay. Now, voltage standard. Sometimes all of you know that this motor or this machine or this fridge or this washing machine works in 110, and the other one works in 220. Or we know that in America, the voltage source, the voltage standard is 120. We know here in Saudi Arabia we have 120 and 220. In Jordan we have 220. In Egypt we have 220, and so on. What's the meaning of 110 and 220? From where we bring these numbers? What's the meaning of 120?
The voltage.
Now, yeah, here now, as we know that the electricity was invented in America, so in North America, here we are talking about AC, as I told you, the AC, DC only in batteries. I didn't need it. The current is an AC, so at our home we have an AC. Voltage of AC in America is normally 120. As I told you, in America, it's 120. In the early days of electricity, higher voltage burned out the filaments of the electric light bulb. So here, in the early days, at the beginning of the electricity, we have a higher voltage. It's burned the filaments of the electric light bulb. You know the electric light bulb? It's burned. So since we have a higher voltage, so it's burn the filaments of it. Now, so that's me. The things I want you to know it here now, that power plants in the United States used 110. This 110 is a voltage standard that's used in America. From the early days, they make an electricity, they make machines, and they used 110. After that, Europe became popular, or the electricity became popular in Europe. So they said the light bulbs were available now, but they didn't burn at the higher voltage. What did they say? They used an 220. So that means America make an electricity, standard voltage of the electricity with 110. They use them. They use them on all power plants. All the equipments, all the things in America are working in 110. But this higher voltage, it's burned the light bulb. Europe now, they make a new invention. They try to fix this problem. They will say now, I will make a new type of voltage standard, but this voltage standard didn't burn the light bulb, which is 220. So they try to fix the problem. They make a new thing, which is 220. This 220, it gives you what? It didn't burn the light bulb. So power transmission now is more efficient at higher voltage. So Europe adopted 220 volt as their standard. So the more efficient for us is 220, which is in Europe. But America cannot make anything. They already make their equipments. They already make their power plants in 120, in 110, sorry, or 120 volts. So the United States stayed with 100 or 120 volts because all of the power plants, all of the installed base, all of the equipments there are working in 110. As we see here we have two electric plugs. The first one for British and the second one for American. Now, before talking about three-wire service, here, do you have any question?
No, teacher.
So, as we say, the word standard, we have 110, or we can say 120, officially 120, and 220. Sometimes you write, if you see at any electric device, you will find them like this, 220 to 240, or 110 to 120 volts, officially. This one, it is in America, and this one, it is in British, or you can say it's in Europe. Now, if you have any electric device that is working on 110, okay? Any electric device that is working on 110, anything, as an example, you bring something from America, it's working on 110, and you want to turn it in a country that's used 220, like Egypt, as an example. You go to America, you bring a fridge that's working on 110. You put it in 220. What will happen? The device will burn. Okay? بيحترق. It doesn't work. But if you have something like your hair dryer with you, you bring it from Egypt, and you travel to America. This one, it can work. but weekly. Okay, so it's better for you to use a 110 into 110 volt and 220 into 220. That means sometimes if you find the plugs like this, sometimes if you find that they have 3 pockets on it, this one, that's mean in your socket wall, that's mean you can use only the 3 plug like this one here. Which one? This one can be used only for this socket wall. So the 220 can work on 220, but the 110, you have here these 2 things here, 2 socket wall. This one can work only on 100 and 110. Now let's talk about, if you see here, we have 3 wires, 1, 2, and 3. What are these 3 wire service? This one we called it, in British, we called it 3 wire service. What are these 3 wire service? All the lamps in American home operate on 110, 120. Electric stoves and other appliances, yes, operate on 220. What does it mean? Here in America, they try to solve the problem. They said, let's make something we called an electrical VCC or VLC. VLC or VLL, I think. It's V line to line. I mean VLL, yeah, I think, yeah. What does it mean? Here now, you have draw it like this. This line here, which represent positive 120. And there's another line which represent negative 120. This is, and there's a third line which represent earthing, or we call them neutral. That's when we have 0. So this one here, we call them 3 wire service. Where are these 3? This is the first one, this is the second one, and this is the third one. 1, 2, and 3. Now, the first one, 120, the second one, 0, and the third one is negative 120. So what does it mean? If there's a fridge works only in 110, the machine used this line, let's make one other lone color. They used only 2 lines, 120. Sorry, they used, oh my God, they used 120 with the 0. So they get a 120 volts. So if there's a fridge work on 120, they use the positive 120 with the neutral volt to get 120 volts. If there's another one, it works in 240. Here we have positive 120. Here we have 0. Here we have negative 120. So if there's any machine needs 240, it's work from positive 120 to negative 120. If you subtract them, you get 240 volts. So the lamps in American home operate on 110 and also can in 220. They try to fix the problem. As I told you, they make 3 things. We call them 3 wire service. Positive 120, negative 120, and 0. If they use, or if the fridge work on 120 volts, it needs only 120 volts. They put one of the wire here and the other one here, so it works on 120. But if there's another electric device, it's need 240, they put their wire one on the 120, or their socket one on the 120 and the other hole on the negative 120, so they get 240. Is it clear?
Yes, teacher.
Okay. So this is an example of electric bulb. This is for British and this is for American. This is 110 volt and this is 240 volt. This one, it has only what is an American. As I told you, we have an American 110, and here we have 240, which is works in British. Now, most home appliances are connected between the neutral wire and the other of the other wires, producing 120. As we said here, most of the home machines, of the home appliances, they are connected, between the positive 120 and a neutral volt to get a 120 volt. And the other are connected between negative 120 and positive 120. That's work and that's make or produce a 240. They are working in air conditioner and clothes dryers and electric stoves and so on. So here, as we said, in America we have 110, in British we have 240. Now, if you talk about safety, more safety, you will find that which one that have earthing has a greater safety than without earthing. So some of the homes if they have earthing, it will safe for you. If it is, that means 110 have a high safety than the 240, because if you have a current that passing through you, it will be less. That means if your current is 5 ampere and you touch anything that works on 120, so the power on your body will be 120 over 5, which is 24. So ما راح تتكهرب كتير. But if there's anything that works in 240 volts and your current, the current in you is 5 ampere as an example, so you will find the power will be 48. So for safety, the 110 is better than the 240. For safety, America is better. But for getting higher voltage, Europe is better. But this is not with you, just an extra information. So here we have two types of current. We have AC and DC. Alternating current, AC, it moves back and forth. It doesn't move in one direction. Alternating current, it moves back and forth. It is in the generator. It is in your home. DC, it's one direction. It's in batteries. Then the voltage standards, as we said, we have 120 and 240. 120 in America, 240 in British. And we talked about the three-wired service or three-wire service. That's if they connects on this wire and this wire, they make a 120 volt. But if it is connecting between the positive 120 to negative 120, the machine can work in 240 volt. Is it clear?
Yes,
Yes,
teacher.
teacher.
Do you have any question?
No, thank you.
It's clear, teacher. No.
No, teacher, thank you.
You are welcome, miss.